Thank you very much for the introduction. Before I begin, I'd like to ask a very quick question to the audience. So, put your hands up if you've ever been so scared in your life, so frightened, that a little bit of pee has come out. Okay, just look at me, look at me. Okay, you can put your hands down now. So that was about 73% of the audience. And hopefully, by the end of this talk, I'll increase that number a little bit, because we're going to talk about web security. And we're going to talk about it through just a series of stories of actual real-life hacks. So I think I've got time for about 3 stories today. But my goal really isn't to teach you anything. My goal is to make you pee yourself. So, as I was introduced, my name is Asim Hussain. You can find me on Twitter at JawAche. FYI, I think as of 5 minutes ago, I'm 6,966 followers. So maybe we can make that a little bit better. I blog about JavaScript and Angular on my site, codecraft.tv, and I'm something called a cloud developer advocate at Microsoft. So you might recognize this logo here for Microsoft. But we're like a new team inside Microsoft. So if you ever see this little creature, which we call Bit, then that means that one of us, the cloud developer advocates, are either speaking out or sponsoring an event. There's only about 30 of us in the world, and I'm part of a small team in there which focuses on JavaScript. So my job is to make web better on Azure. So if you want to speak to me in the drop-in sessions afterwards about anything at all, great. If you want to tell me how much you love Azure, brilliant. If you want to tell me that you hate Azure, even better, because I feed that all back to the PM team. And I'm a course author, so I teach on a site called Udemy. Anybody know Udemy here? Okay, cool. So they recently added in captioning recently, and as Laura said, they sometimes have issues, and they replaced my name Asim with the word awesome, which is something I've been trying to do for many, many years, and it's finally happened. So this talk is going to be very Asim. Okay, let's begin with the first talk. So let me hear about this hack last year, Equifax. Yeah. So it was the largest hack in history. Affects about, I can't remember the exact, I think it's 180 million, 184 million at latest count. It's a $1 billion company. It has like 10,000 employees. But before I kind of dig into kind of what happened here, let me just explain a bit of terminology, because we're not all experts in security. Neither am I, actually. I'm just a web developer that got hacked one day. So I became interested in the subject. So what is a vulnerability and what is an exploit? So a vulnerability is just a hole in your security. So not setting up a firewall is just a vulnerability. That's all it is. An exploit is a script or a sequence of commands, or just even a manual series of steps which you run to take advantage of a vulnerability and do bad things. Has anybody heard of the term zero-day exploit? Yeah? One solitary yeah in the corner. So there's a thing called a zero-day exploit. So a zero-day exploit is one that no one knows about yet. So it's called 0 days. It's been 0 days since it's been made public. But once an exploit becomes public, becomes known, you take off the 0 day and it just becomes an exploit, right? So you might have an exploit that's been known about for 3 months, 6 months, a year, something like that. So how much do you think it would cost to get hold of a 0 day exploit? Or how hard do you think it would be to get hold of a 0 day exploit? The guy? No. It's quite hard, right? You need to roll in the right circles. You need to be the right type of person, right? How hard do you think it would be to get hold of an exploit that's been in the public domain for 6 months? Very easy. In fact, you just Google it. So there's loads of websites. This is one website that there is out there. It's called Exploit Database. I'm searching PHP because it's always fun to search for PHP. So, and if you scroll, as I scroll down, you can see, I made this video at the end of last year, and I think we're still on 2017. So PHP is kind of not, it's classically a kind of It has lots of vulnerabilities. It gets attacked a lot. So you can just kind of Google it, and it has instructions, things you can follow to apply an exploit to kind of attack a site. But I kind of think probably a lot of us here are developers, right? How many of you have spent an entire day writing a script to automate a manual task that maybe took you 2 or 3 minutes, right? All of us, right? We do this all the time. So why do we think that hackers wouldn't do the same thing? Of course they do. There are so many tools out there that automate the process of hacking. This is a famous one. It's called Metasploit. It's used by everybody, really, like white hat hackers, and not so much black hat hackers, but people do use it. And what it does is you can point at a website and has a database of vulnerabilities and literally scan it and say, oh, it's got these 4 or 5 vulnerabilities we can detect from the contents of the site and the way we've probed it. I can also have plugins as well, which actually automatically attack the site, given whatever exploit plugin that you've installed. So fairly straightforward. So back to the question of Equifax. Did Equifax get hacked by a zero-day exploit? No. They got hacked through a known vulnerability in Apache Struts, which is their web framework, Java web framework. A known vulnerability that had been fixed for 2 months, sorry. All they'd had to do to protect themselves was install an update. That's it. Let me repeat myself. Largest hack in history, all they had to do was install an update. That's it. No one wants to be the CTO in that situation. So you might laugh, there's a couple of laughs in the audience, but actually this is really, really common. It's incredibly common. Sneak is a data security firm, and they have some really nice studies, obviously. So they've got this one, which is, I think it was in 2016, I can't remember when, but they did an analysis, and 12 of the top 50 data breaches were just through known vulnerabilities. And I showed you how easy it is to attack through a known vulnerability. So 25% of those data breaches were through known vulnerabilities. There's another one more recently, which is that 77% of, a ton of sites use vulnerable JavaScript libraries. Now the definition of vulnerable is fairly loose there, but it's still pretty interesting. So what can you do about it? I think late last year? Can't remember. GitHub just launched a new feature in the dependency graph. If you've got a project on GitHub and you look in there, I can't see the screen. If you look in there, dependency graph, it'll scan, if you've got a JavaScript file, it'll scan your package dependencies, and it will link it up to those online databases that I showed you, and it'll actually show you if one of your dependencies is a known vulnerability. So I think it now supports JavaScript. I think it's supporting Python now, not 100%, but it's planning to support that soon. Other tools you can use is, from Node Security, you can use NSP, which is kind of just a more command line version of that. You can add it into your CI flow, and it'll tell you if any of your packages have known vulnerabilities. And of course, if you're using Azure, which a lot of you are, if you're using Azure, one of the cool things about Azure, one of the things I like about Azure, because I'm not very good at security, is we have something called the Azure Security Center, which you can just switch on, and it's kind of like a linter for your security. It does a bunch of things. One of the really cool features it has is that you can always have lots of different alerts and signals that you're getting hacked. And if you look to each and every one, it's really difficult. It's oh, is this a real login attempt where someone forgot their password, or is this an attacking attempt? But what we did is we trained an AI to kind of detect patterns through all those. And so only if it detects a pattern of a hack does it alert you. And it's quite nice when you look into it, because then you can see not only that you got hacked, but it's done all the hard work of figuring out how you got hacked. So it's quite interesting, it's quite good. So, summary. It's pretty easy to hack someone through a known vulnerability. They just use an automated tool, and the evidence seems to suggest that this happens a lot more than you might think. So use tools like NSP. If you're using GitHub, use their dependency graph. I use Snyk. Snyk's a great tool. Snyk.io, SNYK.io. And yeah, end of the first story. Anybody scared? No? Did they build them like quite tough in Oxford? Maybe. Right, maybe the next story. Has anybody heard of this company? GitHub. Yeah. It's GitHub, right? Everyone has GitHub. So this is actually, they have like something called a bug bounty, or they take part in a bug bounty. Basically, in a bug bounty, they will pay you money if you find a security hole in their software. Okay? So this is a really wonderful write-up, and this is not, I didn't find this, is a user, a person called Orange Sai. So if you want to, please follow Orange. Great person, does lots of cool little, finds lots of cool little things and posts them on Twitter about security. But this is his report of a great issue that he found on GitHub. And I love this story because it's like a heist movie. Right? It's like, how did they get in? It's a really interesting one. I'd love to share it with you. And I think it's got a good moral at the end as well. So if you use GitHub, it has something called webhooks. So with webhooks, you can configure it so when you do a git push, for instance, it will make a post request to a URL. Okay, fairly straightforward. But what if instead of example.com, put in localhost? What would happen? You'd basically do a git push and it would do a HTTP post request on the same server, behind the firewalls. And you can remember when you post, you can post to a host and a port as well. So you basically post a specific process. But don't worry, this wasn't that easy. So this is GitHub. Right? Obviously, they know what they're doing. So this is something called untrusted import, user import. The user entered that URL. So you need to do something called sanitization. So you run it through a sanitizer and you make sure that they're not putting in things that are kind of hackable statements. So localhost is obviously one of the ones that they detected. But the sanitizer they used forgot about 0. So 0 on some machines can actually resolve to localhost as well. So first exploit, Orange is in. What can you do with this? What can you actually do with this? Now you remember you're doing a post to 0, and a 0 and a port, right? So we're going to play a little game I like to play called guess the port, guess the process. So can someone tell me what 9200 is? Elasticsearch, there we go. It's Elasticsearch. And if you send a post request, a HTTP post request to 9200 shutdown, you shut down Elasticsearch. So not a big denial of service attack. You're basically going to switch off search on GitHub for a little bit. Okay, so that's one exploit. So then Orange read, well, I want a bit more money than that, so started looking around for other things to chain onto the end of this, and then found this little piece of code. So this is Python. And what GitHub also uses is a process called Graphite for a lot of reporting and charting. And this is a root endpoint for Graphite. So this will get called on a HTTP post. And it just sends an email, basically. So I'm going to explain the code for you a couple of lines at a time for those of you who aren't so well, for everybody. So it basically gets the URL from the query parameters. Gets the URL from the query parameters, and then makes a GET request to it. A GET request. Okay? So what have we done? We've basically turned a POST request into a GET request. Second exploit. Or is it? So if you passed in this webhook URL, the whole thing gets posted to, and then it extracts out the red URL and then does an additional GET request to that red URL. Not, such a big issue, right? But looking back at that code, it uses something called HTTP connection library to make the request. And the HTTP connection library had a known vulnerability. In very recent versions of Python, actually, I think 2.71 and 3.44, so not that old, but still there. So it had a known vulnerability. And the vulnerability was something called carriage return line feed injection attack. So carriage return is /r, sorry. Is carriage return, it's new line on Windows. /n is new line on everything else. So a cross-platform way of doing new line is carriage return line feed. You convert that to hex, ODOA. So now what happens when you make a GET request to this URL? Actually, what is a GET request? Actually, what is HTTP? Does anybody know? Does anybody know? Well, we've probably seen this kind of code if you look in the network tab of Chrome. And what HTTP is just a TCP connection, a raw TCP connection between two servers and a protocol. And the protocol is sending in strings, one line at a time. Each of these lines is different strings. And the strings end in carriage return line feed. And it knows, the server listening on the other side knows the HTTP message is finished sending because it sees two carriage return line feeds, one after another. That's the HTTP message. But what the HTTP connection library does is it converts ODOA to carriage return line feeds. So what's going on? What happens? Well, what's going to happen is that the HTTP service that's sitting on the other side is going to go, well, I don't know what this is. Why are you sending me this? This doesn't look like HTTP. It might return to 400 back or something like that. It's like, this doesn't look right to me. So it's figured a way out of like sending a malformed HTTP message to some server. Not a big issue, right? But what about this? Who can tell me the process from that port number? Memcache. There we go. This is memcache. So if you actually try to send this HTTP message, remember memcache doesn't know HTTP. Memcache doesn't talk HTTP. Memcache talks a completely different language. Memcache talks the memcache protocol. But if you actually try to use the HTTP connection library to send that, it would actually send this. Okay? So what's actually going to happen is the memcache is going to get sent this, and it's going to go, why are you sending me this? This is wrong. I don't know what this is. Returns an error. And then it's going to send, you're still going to send it this, and it's going to go, oh, yeah, I know this. Yep. This is me. I'm going to set data on the key. I didn't use a very imaginative names here. And with some timeout parameters in the middle. So great. And then you're going to send it this, and it's going to go, I don't know what this is. Why are you sending me this? Why are you sending me this? Why are you sending me this? Etc., etc. What this is called is something called protocol smuggling. Okay, so you're using a HTTP library to send the memcache protocol. Okay, so what have we got? What have we done? That's weird. So here uses memcache or directly. Some of you. Well, whether or not you use it directly, there's pretty certain there's some part of your process of your stack of applications using memcache. It's a core part of the internet, right? And so often what we do is we want to serialize some data, store it in memcache, then later on we would deserialize it and execute it. That's what we would do, right? Easy. But I've just showed you how to set data in memcache. So you're going to store your code, and you're going to serialize it, and be happy. Then you're going to deserialize your code, you're going to execute it, but it's not your code. It's my code. Okay? Again, what can you do with this kind of stuff? Well, scanning the keys in memcache, orange, found this key. So sometimes when you use libraries to serialize objects, it'll put the name of the class of the object in part of the key, so you can figure out what class created it. And you use this one. You literally use the words deprecated instance variable proxy. So instance variable proxy had a known vulnerability, so they renamed it to deprecated instance variable proxy. So in order to use this class, the developer had to change the code from instance variable proxy to deprecated instance variable proxy as like an admission that I know it's deprecated. I shouldn't probably use it. But they did. We all done it. I'm not blaming anybody. I do it all the time. I don't, actually. But what was the vulnerability it had? Well, the vulnerability it had was that just the act of, you could change its serialized form in a specific way. So just the act of deserialization executed a command on the server. Just the act of deserialization. So the actual end webhook URL is this. I'm going to try and use my fancy new clicker to find. So you see this ID in the middle there? Whatever you stuck where that ID is, whatever command you stuck there, is the actual command that gets executed on the server. Sorry, so the whole thing is the webhook URL, and then the red thing is just what gets posted. Then you remember the get command. Remember the one that was really innocent at the start? It was just a post. Yeah, that was a get command, and the kind of the darker blue at the end is just the data that gets set inside memcache. Okay, and the ID is the command that gets run. So to prove deserves the money, he created a video to prove that it works. So basically go to GitHub. It's actually GitHub Enterprise, but goes to GitHub. Goes to repos. Hooks. Add a webhook. The actual URL is pretty complicated, so he's got a script to like figure it out. Hi. Looks kind of cute. And that's the URL. Just paste it in, and actually to trigger this exploit, what you need to do is you need to do a search. So the act of searching then pulls the data from memcache, deserializes that object, and executes the command. Runs another little command in the terminal to show you what gets run on the server. So now just searching, and then if you look in the terminal, the ID command got run on the server. How you feeling? Bit scared? Anybody need a toilet? Okay, well maybe keep it in for a little bit longer. So, what's a summary of this one? I think it's quite an interesting hack. I think I love this hack because it teaches you that big exploits come from smaller exploits. When we're building our applications, we always think that the hole in our security is going to be this big, obvious hole in the front, and it's going to be really clear how people are going to get in. No, it's not obvious at all. This was 4 kind of very subtle little exploits, which when chained together, made a large exploit. So kind of the summary is I think sometimes we look at some code and we think, that looks like a vulnerability, I'm going to ignore that. No, don't, right? And if you've heard of OWASP, so OWASP is a group that kind of has a top 10 list of security vulnerabilities. They literally changed it recently, which I think is quite interesting. It hasn't changed since 2013. It changed in 2017. So using components with known vulnerabilities, that didn't change. That was there from before. Insufficient logging and monitoring. So that's why I mentioned Azure Security Center. It's getting more and more important to have this kind of stuff. And insecure deserialization is now in there as well. So this is not kind of like an edge case I'm talking about here. It's actually quite a common issue now that's worthy of taking a look at. All right, I think I've got some time left for the final story. Who can tell me what this code does? There's no point zooming in. It grabs the environment variables and sticks them in a base 64 encoded string. Okay. What about the rest of this stuff? So I seem to then take those environment variables, and I seem to be posting them to my server. Who here stores like secure stuff in their environment variables? Yeah? There we go. There's only about 5 hands coming up. Unless the rest of you are storing them, are hard coding them in your scripts, I don't know what you're doing, right? But yeah, we're using environment variables, or if you're using Azure, use Key Vault or something like that. But a lot of us use environment variables to put secure data in. So you should all be really scared of this code. What if I told you I could make you run this code on your server? Would you believe me? No? As the same guy before said yes, I think he knows what's coming. All right, let me give you a couple more clues. So the script is called package .setup. Oh, there's an R there. Okay, in the clue. This is an npm module. And that is a setup script for an npm module. Okay, so I know what you're thinking now. You're thinking, Asim, okay, fine, I get it. If I installed your npm module, okay, you could hack my server. But why would I install your npm module? Then we see this kind of last year on Twitter. All right, so somebody thought that Kent Dodds, somebody thought his cross-env package, somebody had hacked it. But what had actually happened was this. So cross-env is the real one. Cross-env without the hyphen is the hacked one. It behaved exactly the same as the first one. All it had different was that little setup script at the start which posted environment variables to somebody else's server. It's actually a really common problem. It's called typo squatting. It's not just JavaScript. Like, I speak at Python conferences as well, and we have it in Python also. And all languages, really, at the end of the day. And, yeah, it's a bit of a problem. But why is it a problem? Like, I think I was, when I first found out about this, I was like really taken aback. It really shocked me. I took a step back, because I was like, whoa, whoa, whoa. I thought to myself, why am I so upset about this one? And I realized after a while of thinking about it, it's because it's open source, right? We have this kind of implicit trust in open source. It might have bugs. It might have a vulnerability. You can't blame everybody. It might have a vulnerability. It's not going to have an exploit, because it's all public domain. It's like out there. If I turned up to you and I said, hey, I've got like a binary package, right? Can't see the source code, but it's 3 times faster. Go use it. You'd never use it. You wouldn't go anywhere near it, because it's closed source, right? But it's open source. We trusted it. We trusted that people would find it, but those packages were up for, I think, 2 weeks before they were discovered. And that people downloaded them, right? What are some solutions? Well, this is why we have kind of private scopes inside NPM. So if you're publishing something, make sure you use a private scope. And only you can then publish that package name, right? They've recently added in new rules for package moniker naming. So if package name with hyphen is already there, you now can't upload something which only changes the name in terms of what do you call those things? Punctuations. There you go. So yeah, that's helped like quite a lot, right? And there's other things coming down in the future as well. Ooh, one time. So to summarize, you don't want to be that person who has to sit in the room with the CEO explaining why the business they've spent 10 years building is now destroyed because you couldn't be bothered to install an update, right? So just keep everything updated. It's not a joke, right? I know we all kind of get annoyed by we've got to keep things updated, but you really do have to keep things updated, right? It's like the #1 vector attack. It's like facepalm, right, if they get attacked that way. So, yeah, update everything. There's no such thing as a small vulnerability. They can all be chained together. They do get chained together into large kind of attacks, so fix them. And did anybody get scared with the NPM issue? Yeah? Got toilet break afterwards, you're good. I don't have a solution, so here's a unicorn. But yeah, thank you very much. That was it. Thank you very much. If you want to follow me on Twitter, you can follow me at Joik. I'll wait. No? And if you want, I'll post the slides up. If you want to find out any more information about the Azure Security Center, you can go to that link. And I will be outside in the lunchtime, the break and the lunchtime, if you want any questions on anything at all in the slightest. Thank you very much.
Thank you very much. That was great.